On this edition of The Nerd Is In, you'll want to see why 2 plus 2 should not equal 22. In this video, I'm going to be talking about how to input numbers from text boxes, do a little bit of math, as little math as we can, to get an answer, and then spit it out into a label. Now, the last video we created our first C# project, and if you remember, I explained how to relaunch your project. So I have already created this project because I want to explain the code to you. I don't want to sit here and walk through me typing all of it. So I'm going to go into my project folder, and here is my Microsoft Visual Studio solution. So if I double click on this, it will launch Visual Studio, and we can take a look at the program I have created. Now, here it is in all of its glory. So what we have here is we have two text boxes to input two numbers. We have an add button, and then right here in this label we are going to display the answer. And then just for bonus, I put an exit button. So these are all labels right here. I'm sorry, these are all labels right here. These two are text boxes, and these are buttons. So just like if you're going to the play, we need to know the name of the players. So the players that we care about are the two text boxes and the label where we're going to display the answer. So if I look at this text box and come over to my properties window, you'll see it is named TXT num1. And take a big guess about what I named this text box. That's right, TXT num2. And then finally, we're going to display the total of those two numbers in label sum. So that's the players we're looking at. And I want to show you a common mistake because there's some details we have to worry about representation of data on computers in order to make things work correctly. So if I just run this program right now, I'll come up here to the start button and run it. And of course, it shows up on my other screen, but here it is. I'm going to say 2 and 2. I'm going to add them together. And of course, the answer is 22. What's wrong? What's going on here? So that's what I want to explain to you. And here we go. I'm going to test my exit button, and it exited the program correctly. So all the action is happening here in my add button. So I can double click on the add button to bring up the code window, but I already have it right here. So I'm just going to click right here, and let's concentrate on this line of code right here, right now. So remember my players. First text box is TXT num1. That's where I typed in the first two. Second text box, TXT num2. That's where I typed in the second number. What I'm saying here is take what the user typed in to TXT num1 and add that to what the user typed into TXT num2. That's the text property, whatever the user put in that text box. And then finally, once we've added those two together, put them into the text property of label sum, which is this label right here. So what's going on, though, is the representation of the data and how computers handle different data types. Text is a string format. The data is organized so we can read a message. Okay? It is not organized on the computer in a way that we can do math easily. And I put a couple little slides together to kind of explain this. So let me fade to these slides so we can see what's going on. So let's talk about how a string is stored in random access memory. Each character is stored as a number code. Now, I'm simplifying. Strings are now, each character is now stored as a Unicode, which is probably 16 bits, not 8 bits. But for instance, in ASCII, the American Standard Code for Information Interchange, the letter A is stored as the number 65 in memory, because RAM can only store numbers. The letter B is a 66, the letter C is a 67, and so on and so forth. Lowercase letters all get different codes. The number 0 is stored as a 48, a 1 is a 49, and a 2 is a 50. And these are just stored in sequential memory locations. So this all together is a string. Now, as we go through these videos, we'll be using the term strings and text interchangeably. A string and text is the same thing, okay? But how are numbers stored in memory in a way that the CPU can easily do math? So I'm incredibly simplifying this, but say we take the number 155. Everything is stored in RAM as a series of zeros and ones because that's all that memory can hold. So the number 155 in our numbering system is actually stored in 8 bits with this series of zeros and ones. Now, you're not going to have to know this. You don't have to memorize a bunch of zeros and ones to be a programmer. The number 42, for instance, is stored as this bit pattern. This bit pattern right here is the format that the CPU can work with to add things together. It can work with zeros and ones and put them together to get the answer. So the problem we run into when we're trying to do strings in a programming language is the programming language looks at the format of the data and goes, you have a string text that is the number 2. We want to add that to another string, which is the number 2. And if we add those together, it just concatenates the string into a longer string. It takes the 2 small strings and glues them together. So we don't get the results we want. We're going to get 2 plus 2 equals 22, not 2 plus 2 equals 4. Now, if we have the data stored in RAM in number format, in binary format, here's the binary representation of a 2 plus 2. The CPU is going to do math on that. It's going to add it together and store it back into RAM with the binary representation of 4. So when we input stuff from text boxes, well, that gives it away. It's a text box. It's a string. We have to then convert it to a number so that we can do math with it. So let's jump back into our program and I'll show you how to do that. So here we are back in my exciting, wonderful program. And you can see the code I have right now is adding 2 strings together. It's saying, take what is in txt num1, add that to txt num2, what's in txt num2. So since these are strings, 2 plus 2, it's going to get 22. It's going to get a longer string and put the answer in label sum. So if we go back here, if we have a 2 in here plus 2, it glues those 2 strings together, or we say concatenate, and it puts the answer right here. So if I run the program, this is obviously the behavior I do not want. 2 plus 2 equals 22. Incorrect. Let's look at what we really want to do. Now, this line of code is the wrong code. Now, I'm going to comment the code out by putting 2 forward slashes in front of it, and this just tells the compiler to ignore this code. And I have conveniently put the correct code down below, commented out, and now I've uncommented it. So let's look at what's going on right here. In this line of code, I'm taking the contents of txt num1, the first text box, the text property. I'm saying parse that string into a decimal. So this command right here is going to convert what's in txt num1 into a decimal number and store it in random access memory in desc num1. So what's desc num1? Well, if you look up here, I have defined a variable to hold a decimal. So what's a variable? I'm asking the compiler to set aside enough RAM to hold a number. The name of that memory location is desc num1, and it's of type decimal, so it can be dollars and cents. It has a main part and a fraction. It's not an integer. It can have a full number. Okay? Then I've done the same thing. I've created a second memory location called desc num2, DEC, to remind me it's a decimal because I created it as a decimal. And this is going to hold the contents from the second text box once I convert it into numbers. So if you look here, I've got two inputs. I have to take this string and turn it into a number and store it in RAM. I have to take this string, convert it into a number, store it in RAM. Then I've got to add the two together, store the answer in RAM, and then turn it back into a string to put it into this label. So that's why I've created a third memory location called desc answer, which surprisingly is going to hold the answer to adding my two numbers together. It's also a decimal. And you can see right here, after I have converted the strings into decimals and stored them in desc num1 and desc num2 in RAM in those variables, the next line of code is add the two together. Once you get the answer, put it into the memory location called desc answer, and then finally we have the answer. It's wonderful. Life is great, stupendous, excellent, overwhelmingly great, except now we got to put it in the label so the user can see it. So I say desc answer to string. That turns it into a string again. Then I can put it into .text of label sum. So here's my input. I've got to input my two numbers and take the strings and turn them into decimals, into numbers I can work with. Then I can do my math. And then finally, I have to take that decimal number, turn it back into a string, and put it into label sum. So now, if I run my program, well, let's build it first. Build solution. And you'll see my build succeeded. I have 0 errors. That's good. Now I can run my program. So now, to the great excitement, 2 plus 2. When I hit the add button, I get 4. Seems like a long way to go, doesn't it? So I'm going to hit the exit button. By the way, my exit button, I just have to have the command application.exit to tell my program to shut down. That is that button. Now, the other thing I can do to show you this running is to step through it with the debugger. So I'm going to go back to my code window, and right here in this gray margin, I'm going to click once and I get a red circle. This means pause my program when you hit this line of code. So then I can see what's going on in my program. So I want to step through this with the debugger. This is what I'm going to be doing over and over again in these programs I show you. I'm going to start my program. Let me get it on the screen again. Here's my program. And we'll say 2 plus 2, add. So now it has gone through these lines of code and it is paused right here. Has not run this line of code yet. Okay? You see the little yellow arrow and the yellow line? If I hold my mouse over .text, we can see there's a string in that text box, txt num1, with a value of 2. And if you look at the tooltip, it has double quotes, 2, double quotes. So that tells me it's a string. Now, if I look at desnum1 right now, it has a value of 0. That's because I have not run this line of code yet. So if I come up to my toolbar right up here and say step over, it will run this line of code. Now that it's run that line of code, you can see desnum1 has a 2 in it. Same thing here. In txtnum2, we have the string. We have a string with the value of 2. We don't have anything in desnum1 yet because desnum2 yet because I haven't run this line of code. So I'm going to come up here and run it. And by the way, you see you could hit F10 on the keyboard, but I'm just going to hit the button up here. So now I have my inputs. I have 2 and 2, and they're stored as numbers because you see they don't have quotes around them. So when you hover over something in the code window, a variable or a control, it gives you a tooltip and shows you the value of that property. So now what I'm getting ready to do is say 2 plus 2, and the answer is going to be 4, once again, once I run the line of code. So now I got a 4. The last thing I got to do is take desAnswer, turn it back into a string, and put it into label sum. So I'll say single step, step over. So now you see label sum has a 4 in it, and it's a string because it's got quote, 4, quote. So that's what you have to do to input numbers. Now the reason this whole line right here is in red is because I've set a breakpoint. Now if I come back over here and click on it, the breakpoint will go away and the program will just run normally. The arrow right here shows me where I currently am. I'm just going to come up here to the continue button and tell my program just to continue. And now you can see my 4 is displaying. And then I can exit the program. So I wanted to just show you what's involved when we want to do math in programming. We have to sweat the details. We've got to take the strings, turn them into numbers, and once we've turned them into numbers, to put them back on the display, to do it properly, we have to turn it back into a string. So let me show you one more thing here, that this program has got a serious problem. Because if I try to come in here and say Bubba plus Sue and hit add, this program's going to roll over and die. Because what's happening here is it's trying to take the string with the value of Bubba and parse it into a decimal. Since that is not possible, Bubba is not a number. Bubba is an individual. He has value. He is somebody. He's not just a number. The program says, I cannot turn Bubba, the string Bubba, successfully into a number. So you see here we have system format exception. Now, we're going to learn how to handle that later, not in these programs. In these programs, and I'm going to come up here to the stop button, stop debugging, and if I was to run the program again and just put in the right values, then everything will be happy again because I can come up here and say 45 plus 55 is 100. We're going to learn how to handle those kind of errors in later videos. But for now, I just want you to be able to see what it takes to input a couple numbers, turn them into numbers, do the math, and then output the answer. I'll leave this up on the screen, but please, if you would be so kind as to like and subscribe so you'll know when I have future videos. Thanks a lot.